and my colleague Ritesh will explain the technology behind it.
So piezoelectric technology essentially uses mechanical energy and converts it to electrical energy with a force that's applied on a certain area. So that example can be seen within a lighter. When you press the trigger, the crystal is pressed, which then sends a current up through 2 wires and produces a spark. And that's also seen in watches and also floors where piezo discs are put in series. And as you step on the floor, it produces volts of energy. So our solution is basically a piezoelectric keyboard where as you are typing throughout the day and just continuing your work, there is a piezo disc underneath each key. And as you type, it will store the energy in a battery pack, which then you can use to charge whatever device, your phone, your laptop, anything like that.
And so the total addressable market just for the keyboard itself is 4.7 billion. And then the serviceable addressable market for niche keyboards such as mechanical gaming keyboards is 1.3 billion by 2023. However, I got the serviceable obtainable market by taking the technology adoption curve into market, since our technology is relatively pretty new, assuming that only the early adopters and innovators are going to use this product initially. So that's around 16% of the total market, which 16% of 1.3 billion is 208 million. And so why now? Expensive clean energy, such as solar, hydro, wind, geothermal, and biomass, they're an expensive and hard barrier of entry for regular consumers to really adopt. However, our technology is cheap. It's used in devices that everyday consumers already use, and our keyboard idea is still going to be that cheap and also provide that clean energy source that everyone is looking for. So the customer segments that we are going to start with are public schools, tech enthusiasts, and offices. Public schools, they utilize keyboards and computers in their learning, and also allowing this technology to be used in public schools will help educate the youth around renewable energy and piezoelectricity. Tech enthusiasts, they're going to be part of that early adopter market that's going to use this technology and also help us to expand this keyboard and the technology of just piezoelectricity in general to the wide customer market. And then offices, because they utilize keyboards, and they're just going to be a very big, powerful customer segment for spreading piezoelectricity, and they're also very conscious about renewable energy. So the financials. So estimated price to produce a regular keyboard, not piezoelectric, is around $22 on average. And for a piezoelectric crystal, the rate is around 2 cents right now. And on a standard keyboard with 78 keys, that in total is around $15. And then our estimated cost to produce this keyboard or cost to purchase the keyboard is going to be around $75, which is around the same as the niche gaming keyboard, mechanical keyboard market. So KPIs, so units sold, and then energy saved and product reviews. These are really going to help determine, are we going to be successful, and is this technology well received throughout the customer market? So the potential impact that our piezoelectric keyboard is going to have is that, although like keyboards are, they seem like they're simple and not glamorous, they're used by millions. I'm sure that, every one of you use a keyboard every day, so having a piezoelectric keyboard will just help the regular customer market be able to, again, like adopt the whole renewable energy industry. And then also we want to become a leader in like inclusion and equity. So we want to hire people from disadvantaged communities. We want to donate these keyboards to schools. And by donating keyboards to schools, we will help educate the youth on the benefits of renewable energy. And so the team is myself, my friend Ritesh, and also Riaz Rudin. We are from the University of Connecticut. We are product designers, engineers, and programmers. And also we're all entrepreneurs and innovators that have worked on previous or working on innovations currently.
Okay, thank you very much. Are there questions from the judges?
Yes, thank you. What, I guess, what was the nature of the customer interviews you've done, or have you done any customer interviews, and what was the feedback?
Yeah, so personally, I've done a little customer interviews with other UConn students, and they all really like this idea because, student Gen Z, especially, they're really, conscious about how much energy they're using or saving. And they feel like, and a lot of them are, either gamers or students working on computers, which utilize keyboards. So they like the combination of this renewable energy technology with, something that they use every day. And that's the feedback that we received.
Great, thank you.
Okay, thank you very much.
Thank you.
Let's see, the next team we have, which is team number 6, is electromagnetic power generation using treadmills. And the lead presenter is Dylan Palmer from Syracuse University. So if you'll go ahead and share screen, we'll get started. Okay.
All good?
Yep.
Okay, so our technology proposes an electromagnetic treadmill. This treadmill will be completely self-sustaining, and it will capture excess energy that is expended by the user. This treadmill will also last longer because there are fewer moving pieces. Electromagnets will replace many of the mechanical parts, and therefore it will increase the durability of the treadmill. The way this works is the user's body weight will initiate the belt, which will start the flywheel, and then that will generate energy. And then replacing the traditional motor will be a microinverter, and that is what makes our treadmill cleaner. The microinverter will clean man-made power and turn it into electrical energy. This treadmill can generate 40 to 200 watts of AC power. This will be fed back into the gym to make it more self-sustaining. Some of the theory behind this is when the treadmill spins, so the electromagnets, these electromagnets come from the DC generators. These generators will be positioned in the treadmill such that the rotor spin opposite to one besides it when it turns. This will result in fields generated 180 degrees out of phase. This power can then be directed to wherever we need to use it. So the market analyzation is, the market for this project is pretty large. We think that this could be used in public gyms, hotels, and athletic facilities, as well as at-home gyms. So the main competitor we found in this market was the Sprinter's treadmill. This specific treadmill uses strictly human force to move the surface of the treadmill. The Sprinter's treadmill fails to capture power that's exerted by the individual, and it is very expensive, as you can see in this little diagram. Meeting unmet needs. Capturing the human energy would greatly decrease power usage across the gyms. By making a treadmill that can capture human energy, we can manipulate technology so that it becomes either net zero or net positive. And as of right now, there are no net zero, net positive gyms in the US. So our economic feasibility analysis is a reasonable cost for our product we think would be $1,800. This price range is below other treadmills that are magnetic based. By making our product cheaper, we believe we can produce revenue while providing to lower income areas. Here's like a cost overview of what everything would cost. So lithium ion, I mean, I don't need to read this, but the total estimated cost of our treadmill will be $650. This is just an estimate. It obviously leaves plenty of area to provide a profitable and affordable product. And we understand from a business aspect, we will need much more money to make this happen, money that will go to production, labs, transportation, advertising, partnerships, all of that. So beneficiaries of this, we think, could be gym owners. They could operate their prices, operating prices will be cheaper due to self-sustaining energy. And then we believe that this could open up gyms in lower income areas because it would be cheaper to run the gym. And then the customers would receive a better workout because our belt will be more resistive than a normal treadmill, providing a better workout. The role in the energy transition is it lowers carbon emissions. By making gyms self-sustainable, we lower the need for electricity from the grid, which in turn lowers carbon emissions. Making all the gyms self-sustaining could then lead to a large reduction in carbon emissions. This treadmill will generate AC power from the user through electromagnets. This eliminates the need for fossil fuels in our system. Our business plan would look like the following. We would want to design an electric treadmill that can produce AC power from its users. 50% of the gyms in the Syracuse area become self-sustaining through these treadmills. At least 2 gyms open up in a low-income area in Syracuse and reduce carbon emissions in Syracuse gyms by 40%. And then to make this happen, we understand we'll need resources, access to a firm or a lab that would allow us to design this electromagnetic treadmill, and then access to a team of engineers with experience that could help us refine our technology, and then a partnership with a professional engineering firm. This firm would have to be in the Department of Energy, and then obviously money. And then I think that's all.
Okay. Okay, thank you very much. Are there questions from the judges for our team?
Yeah, thanks guys. Have you guys done a sort of side-by-side about what a typical gym will use with respect to the treadmill energy use, and what this potential model could provide to see what, to assess the feasibility of this for using for a full gym?
Yeah, I'd be willing to answer that. Sorry, by the way, I don't know why my video is not working. This is a weird device, but we did request out to some of the campus management up at Syracuse, trying to get some information on the usage of like the Barn Center, for example. We sent that out maybe 3 weeks ago. I've sent 2 follow-ups and have not gotten a response. So we had intentions of doing like a side-by-side comparison and seeing kind of what the Barn Center might utilize, which is our on-gym campus, for those not familiar. We have not reached out to any other gyms, but I think that would be a good analysis to include going forward.
Yeah, agreed. Thank you.
Other questions? Okay, thank you very much. That was interesting. So if the next team, you'll share screen and let me introduce you. The next presentation or pitch is 3D nano-architectured battery. And the lead presenter is Katja Sablina from Cornell University. And there you are. Welcome.
Thank you. Just give me 1 second. Good afternoon, everyone. My name is Katja Sablina, and I'm a member of the 3D Battery Team, the innovative team from Cornell University working on a revolutionary new design of battery architecture, where we're using the internal 3D interpenetrating nano architecture of the battery itself to overcome current limitations on the charging times of batteries, among many other pain points. Now, why would someone be interested in innovating the battery industry? Well, let me tell you, the current total available lithium battery market as of 2021 is enormous. It's $40.5 billion with $10.5 billion serviceable market, which is continuing to grow. However, most available lithium batteries face major drawbacks in performance due to slow charging, scalability issues, and safety concerns. With the serviceable attainable market of $500 million available to us, our 3D battery opens a plethora of opportunities for the industry. But first, let's talk pain points. While we'll address many challenges with conventional lithium batteries, a major one is slow charging. Imagine 2 cars, a modern fully electric Tesla and a gas-operated BMW, both equal in price. It takes 8 to 10 hours to fully charge the Tesla, while a BMW will be full in less than 2 minutes. This major drawback suppresses the EV market from reaching every customer interested in getting a sustainable vehicle. So this problem can be extended to every personal electronic device. Wouldn't you like a laptop that charges in 2 minutes? What do we do to achieve this? Well, let me tell you, our team is dedicated to solving this major drawback by reconsidering the architecture of the battery itself. The batteries in your phone charge in a few hours and have a separator of about 20 microns, which the ions have to travel across to charge. Charging time goes with the distance squared. So now take our 3D battery, which has a separator on the scale of nanometers. This is like if you suddenly had to walk only 1 foot instead of 1,000 feet to your favorite coffee shop. So following the same charging time relationship, our battery charges in about 60 seconds or less. So our secret sauce lies in our patented technology that has been published in a high-profile journal and is highly cited thanks to its exciting advantages. Much faster charging is just one advantage of the 3D battery. Our technology also has the advantage of scalability due to all components being solution processable. Another massive edge we have is our battery's focus on architecture over materials. Our design can be applied to any new battery chemistries that may be innovated, so it can adapt to the market and will not become obsolete. And of course, we have the advantage of safety due to our design being solid state. So we now have a device, but who's going to want it? We're currently evaluating our target markets and potential customers. Within the SOM of $500 million, we're primarily targeting personal electronic manufacturers and renewable industries such as solar and wind. So these are just a few of the names that would be interested in our technology. Who would benefit if we reached our target markets? Well, everyone who uses rechargeable batteries. It's around 5 billion people around the world. If there was an option to charge a phone in a minute, wouldn't you want it? In addition, these batteries would contribute to more accessible devices due to their scalability and would incentivize the transition to EVs by removing the pain point of slow refueling. The technology would remain robust in future transitions thanks to our focus on architecture. So when cobalt and nickel-free or recyclable battery chemistries come out, we will immediately be able to adapt. So where do we see ourselves in this competitive matrix? Well, our axes are ease of manufacturability and feasibility. Ease of manufacturability correlates to using accessible methods of manufacturing. Feasibility is flexibility of the technology for use in different applications. So most of the newer technologies require serious redesign of the batteries and their applications. The top right quadrant, as you can see, indicates the materials that are easy to manufacture as well as highly versatile. And as you can see, we're high on both factors and are looking to capture that untapped space. Step one to defining success has already been accomplished in our proof of principle. Next, we are working on optimization and processing. At a bird's eye view, we define success as our introduction to the market. And if that venture is successful, everybody will want our batteries in their devices. We also acknowledge our diversity as a part of the success. So now let's talk about how we will make money. We plan to start our business with a Tesla-like model, beginning with high-end, ultra-fast charging personal electronics as our target market. We anticipate customers would pay more for a battery that charges thousands of times faster, with an expected deal size of about $1,000 per kilowatt hour. As we gain income, we will develop R2R processing techniques to bring costs down so we can enter market of general consumer electronics. And on that note, I would like to present my amazing team. It's myself and William Tate, both graduate students from Cornell University. And also our team advisor is Professor Uli Wiesner, who developed this technology and has had ample experience in converting university research into startups. Thank you for your attention. And now we are open for questions.
The presenter said it all. Are there questions from our judges?
Perfect. Yes, question for you. So you talked about some of the competitive landscape. Obviously, some of those companies are well versed in battery manufacturing and forward thinking. Have you considered with this patent approaching some of those potential competitors because they already have pre-built manufacturing capabilities and they've already got some market share in that space?
Yes, absolutely. The answer is yes. We've been approaching them and we've been doing some customer research. So pretty much we're exploring this. We're again in the exploratory phase. So we're still exploring our target markets, and I think there's more to come. But yeah, definitely competitors is our number one priority, and we're reaching out to them to learn more about manufacturing facilities and stuff like that.
Thank you.
All right, thanks very much. We're going to have one more presentation and then take a brief break after the next presentation. The next presentation is entitled FTF Generators, which I believe means Farm to Flame, the Universal Biomass Solution. The presenter is Kwaku Jamvi at State University of New York at Binghamton. And please share your screen. There we are.
Okay. Hi, good morning. My name is Megan. I'm a sales engineer at Farm to Flame Energy, presenting for them today. We consider ourselves the Universal Biomass Solution, and I'm here to talk to you about how our company produces clean and affordable energy using biomass waste. The problem we're tackling is the mismanagement of an abundance of biomass waste in the US, coupled with a lack of affordable renewable backup power. Currently, diesel generators are widely used as backup power, operating at twice the cost of the grid. In developing nations, diesel generators are used for approximately 8 hours a day, costing businesses millions of dollars per year in backup energy alone. So our solution is our farm to flame generator, which is able to provide the lowest cost renewable baseload power on the market, operating at 14 cents per kilowatt hour. The generators leverage our patented smokeless and odorless combustion process. Farm to flame's combustion process overcomes the low fuel flexibility and portability typically associated with burning biomass for electricity. Our fuel processing procedure allows us to quality control our fuel with machine learning to ensure continuous power generation. The core of our innovation is our generator's ability to procure the blue flame and achieve a higher level of thermal efficiency, resulting in less smoke and carbon monoxide levels under 40 parts per million. Moving on to what makes our product a strong competitor in the renewable energy industry, other biomass electricity generation solutions have proven to be unscalable. Our on-site 24-hour solution is unique because it is affordable, scalable, and sustainable. Other popular sustainable solutions out there include diesel generators or natural gas generators, which are fossil fuel-based and expensive. Solar by itself, which is affordable, but when you pair it with storage, it becomes the most expensive of the solutions. And finally, anaerobic digestion, which deals with methane, which is more harmful to humans, ecosystems, and crops than carbon dioxide is. Farm to flame is the cheapest of these options and provides two distinct biomass energy services, electricity and heating generation. These systems integrate seamlessly into the existing infrastructure of commercial scale buildings, which makes it simple for our customers to transition from their current energy provider and experience savings from day one. We handle the design, installation, maintenance, and fuel delivery, and then we charge our clients on a power purchase agreement or PPA basis. In the past 12 months, we've made a lot of progress in securing grants and clients, which has allowed us to jumpstart our pilot programs. We hope to use this foundation to achieve our ambitious expansion plan. The Northeast is known for the most expensive electricity in the US, and many are seeking renewable alternatives. If we were to repurpose all of the available biomass in the Northeast and sell it as electricity, this would be a $1 billion market. After the success of our pilot programs in the Northeast, we plan to move to the developing world, specifically in Nigeria, to replace diesel generators and ultimately save 150,000 lives per year and open the door to a $10 billion revenue opportunity. Our first customer is a vertical farm in New Jersey who will purchase electricity from our 30 kilowatt generator at a 14 cent per kilowatt hour rate. This partnership is going to generate $30,000 in recurring revenue. Our next step is to build a 1 megawatt generator this year to streamline our energy production. It will supply electricity at 21 cents per kilowatt hour, generating $1 million in recurring revenue. Heading into 2024, ideally, we will have achieved expansion into Nigeria and will be producing and distributing a 3.5 megawatt generator, producing $4 million in revenue per year. Our student-run funding and sales team, myself and Samantha, is passionate about expanding our energy as a service business model. On the sales side, I'm responsible for building relationships with clients, and on the funding side, Samantha is responsible for securing the funding to make pilot projects possible. We work together to ensure that when a client signs a contract, there is funding available to start the project straight away, making the company's expansion goals truly attainable. I'll conclude by saying how excited we are to participate in this program here today, and thank you for your time and consideration. Any questions?
Yes, thank you very much. Do our judges have questions for?
Yes, thank you. Great presentation, Megan. You touched on this a bit, but what activities do you think you would be working on in which your technology can support members of disadvantaged communities?
Yeah, so I'll hop in for Megan. This is Kwaku, CEO of Farm to Flame Energy, and I'll just hop in and assist them in the Q&A. But for disadvantaged communities, for example, we just received some funding from the Richard King Mellon Foundation in Pittsburgh, and that helps us to put these generators down at 14 cents per kilowatt hour. Our first megawatt is actually, the power purchase agreements are going up for 21 cents per kilowatt hour. But we're doing this especially for Pittsburgh because there's a lot of members of disadvantaged communities here, and it can help commercial buildings transition towards sustainable energy. But this is also with no capital cost on the generator. So for the 30 kilowatt generator, it costs around 75K, but they won't upfront that capital cost, and we'll be working with special project financing to allow our revenue to go forth with that.
Great, thank you.
Okay, thank you very much. We're going to take about just a short 5-minute break now. The next presenter, who's from SUNY Binghamton, Dominic Caracciolo, can go ahead and share slides so we're ready when we start in about 5 minutes. Okay, so I'd like to get started again. Let me just verify that the judges are back.
I'm back.
I'm back.
Okay, and is Jackie back? Let's wait for Jackie then. Oh, there you are. Okay, great. Just sending you a message, which we will now skip. Great. Okay, so let's get going again. So as you can see from the slide, the next presentation is, let's see, I make sure I've got it right. Yep, a slight change in title. High durability nanoalloy catalysts is what I have, but high performance hydrogen fuel cell is the slide presented, I believe, by Dominic Caracciolo, and he'll correct my pronunciation from Binghamton. So please get started.
You got it. Thank you very much for inviting me. I appreciate this opportunity. My name is Dominic. I'm the founder and CEO of Domcat Technologies. And today I'm going to talk to everybody about my product for a low-cost, high-performance hydrogen fuel cell. So I always like to let everybody know what a fuel cell is. It's a lot like a battery, but battery, what it does is it stores energy, and a fuel cell, what it does is it converts energy, and it uses hydrogen as the fuel and oxygen as the oxidant from the air around us. So this process generates electricity, and its only pollutant, I use that lightly, is pure water. But there's a little bit of a problem with the fuel cells in that to get them to actually work, you need a catalyst. And unfortunately, these catalysts are incredibly expensive and they're incredibly rare. The favorite catalyst of choice is platinum, palladium, and rhodium. So that is a huge problem. These metals are incredibly expensive. Anybody that follows the markets and likes to play with the stock exchange, especially in the precious metals, they see that platinum, palladium, all of these rare metals are going up in price. And they're also a little bit unreliable. Platinum does not last very long in a fuel cell when it's being used. Average shelf life of these fuel cells is about 6 to 12 months. And these manufacturers, they really want to see this shelf life expand with their current performance. So, like I said earlier, we're focusing on platinum as the catalyst of choice. And they want to see the life of these fuel cells expanded up to about 4,000 hours of regular use of just, getting in your car, driving it to and from work. And current market estimates have platinum rising in price to just around $15,000 an ounce within the next 5 years. So these are some major problems that these fuel cell manufacturers are looking to address. And they're looking to people like us, the researchers, to figure out if we can deal with these issues. So we do have a solution. Right now, what we do is we have a pure platinum catalyst, and we actually dope it with some cheaper metals. And what these cheaper metals do is it removes a lot of the platinum that's actually going to go into a fuel cell, reducing manufacturing costs by about 40%. And we've also noticed a really interesting trend where these metals make the platinum more stable, lasting up to 30% longer than pure platinum catalysts. So from that, we actually started, myself and Rick, who could unfortunately not be here today, we did some market discovery. We actually joined the NSF Core program, and we started talking to some of these major players as well as some other competitors in the market. And we were able to find out that, yes, this is a major problem that they're looking to address. They need to get the cost of these fuel cells down because they want to be competitive with combustion engines. They told me that a regular fuel cell car costs about $6,000 market price, whereas right now combustion engine vehicles cost anywhere between $20,000 to $30,000. So it's really hard to get people interested to buy their cars when they can get a combustion engine for much cheaper. The market is booming. It's the catalyst market is about 1.8 billion worldwide. And in the States, on this side of the world, we're looking at addressing $100 million. So right now we're first our phase 1 and phase 2 for our company. Phase 1, we're trying to actually scale up our technology. And we actually have a estimated cost of production at about $2,000. And we compared the cost of the catalysts that are on market right now. And we believe that for one fuel cell, we can sell $7,000 worth of our product for one working fuel cell. And once we get past of our scale up in phase 1, we're going to start actually working on selling our product to some of the major consumers of this, like Plug Powered and Ballard. Our market, our plan is focusing strictly business to business, and as well as we do our own in-house processing and quality control, but we do need to transition to an industrial scale manufacturing. We're only able to make 0.1 milligrams or 0.1 grams of this in a day, but we need to make a lot more to meet market needs. And what we're actually hoping for is we want to introduce a new manufacturing facility, hopefully in New York State. I think that would be amazing. This would generate some green energy jobs for the region. And hopefully this will also lead to stronger partnerships with major players in the green energy sector. So I think I'm running out of time, but this is just a financial snapshot of our plans and where we're planning on going. And at this point, I would just like to thank everybody, and I'm open to any questions.
Thanks very much. Do the judges have questions?
Yeah, hi. Hey, Dominic. Thank you for putting together this presentation. The crux of the fuel cell usage that you mentioned in the presentation was primarily for transportation. Is this also transferable over to stationary fuel cells as well?
I believe so. The big transition between that would be the manufacturer size. So the cost analysis that we have for manufacturing is based on a single car. For stationary, it's much more. So I would be very interested in talking to major manufacturers that make solely stationary based equipment, learn a little bit more about what they need in terms of performance, durability requirements, and then also learning how much they would need at any given time. Like I said, one of our big challenges that we need to address is scalability. We can very easily make 0.1 gram a day. We did get some funding through Fuse Hub just recently. They gave us $50,000 to move into scale up. And we're hoping to be able to make at least 20 grams a day to be able to meet major market for transportation. If we included stationary, it might be more, which would require more funding and more manufacturing facilities, larger manufacturing facilities.
Understood. Thank you.
Thank you.
All right. Sounds good. If there's no other questions, we'll move on. Thanks very much. Please unshare. And our next presenter is from Rutgers University, Gianfranco Serna, who'll be speaking on energy in the air.
Oh, there we go. Why is this not letting me unshare?
In due course.
Sorry. Thank you.
We call again for the presenter from Rutgers, Energy in the Air. We didn't take attendance, so I don't actually know if a representative is here or not. So the plan, if we knew that one or two presenters weren't sure they were going to be able to do this today, so the plan will be to move on to the next presenter in about 1 more minute. And just so that person is warned, it's from New Jersey Institute of Technology, Lashawn Wong, low-cost multi-use solar emergency powerhouse. So we'll go to there in about another minute.
Sorry, the call right now, Eric, is for Team 11, just so I'm tracking.
Yes. Is Team 11 here? We did know that 1 or 2 teams were uncertain, so it's not a shock or anything. Okay, so let's move on to that would be Team 13, Low Cost Multi-Use Solar Emergency Powerhouse, if they're here. For whatever reasons, the teams at the end were the ones that were less certain. So, okay, we'll give them about a minute. Team 13 is here. Yes, that you will. Oh, okay. Sorry. I got a message that Team 13 is here, but they're not yet responding. Okay, I'll move on to Team 14. If Team 13 lets me know, we can put you at the end. Okay, so Team 14 is from Trisol. Prathamesh Patil is the presenter, and it's a 3-in-1 solar skylight system. Okay, so if you can share your slides, we'll get going. Yes, good. We have a presenter. Okay, excellent. I'm not getting audio from this team.
Oh, can you hear me now?
You're very weak, but yes, Johan, you'll need to start at the beginning. We'll restart the clock, but yeah.
Okay.
At least I couldn't hear anything until now.
Let me try bringing my mic up. This feedback.
Well, despite 2 years of Zooming, it's still not so easy. I cannot hear the speaker. This is Eric. Prathamesh. Yeah, so you know what I'd like to do, Prathamesh? I'd like to move on to the next person and let you see if you can resolve this problem. And then we'll come back to you if you can. At least I can't hear you, and I'm not getting any indication on my chat line that anyone else is hearing you either. These things happen. You can try logging off and logging back on. Sometimes that helps. All right, so I'm going to move on and hope we can get back to you, Mr. Patil. Okay, so the next team is Team 15. The title is Solar Cruise Electric Scooters Using Solar Energy. And the principal is Lucas Cruz at Rutgers University. So if you can share screen, Mr. Cruz.
Hello, how are you doing today?
Well, as far as Zoom goes, we could be doing better, but we're doing all right. And if you have slides, share them. Yeah, there you go. Great.
Awesome. One of our team members isn't here yet, but hopefully he'll be here soon. Rukia, would you like to do the final three? Rukia, can you hear me?
Sorry, you. If you're ready, that would be great. If not, then we'll try. We'll find an alternate.
One of our team members isn't here yet.
Yeah. No, I know we're ahead of schedule due to the multiple teams that didn't show yet, at least 11, 13. Yeah, the part of this is just scheduling problems, but we weren't that far ahead of schedule, so I'm not quite sure what this is about, but okay. Yeah, no, Eric, if you're not ready, you're not ready. So
I apologize for the delay.
No, it's yeah.
Eric, this is Andrew Graceffa. I would just notify that we do actually have a little bit of additional time since we might be running a tiny bit early. So would you mind if I ask one of the previous team members a question?
Sure. Let's use some time wisely.
If team 5 still on the line about the piezoelectric keyboard?
Yes. Yes.
Hey, how you doing? Quick question that ran into my head is that, about well, actually it's two questions. One is some type of estimate of generated power from like a relatively active user. I don't know if you had put an estimation on that. And if there's the ability to potentially, instead of doing an external charge sort of capability on the devices, if I could see something where a Bluetooth, powering a Bluetooth keyboard could be of use as well. So there's just an internal battery that's charged based on activity. I don't know if that had been under consideration either.
Yes, we've been considering multiple features and applications. In terms of power generated, my engineering co-founder did some calculations. He estimated about 5 volts per hour, but he said that was a little low. And he said that if we moved from the crystals to the piezoelectric discs, it would generate even more power. So he hasn't run the calculations on that quite yet, because we were focused on mainly crystals up until a few like a day or two ago. But at the minimum, it's around 5 volts per hour for a like a medium active user on a keyboard.
Good. Thank you.
Thank you.
Okay, I think one of the teams is, team 14 is now resolved whatever the problem was with their audio. So if the current team wants to unpresent, and we'll let Pranamesh try to get everything ready.
Sounds good.
Eric, this is Jamie Newtown. Could we just, back up? Yeah. I want to make sure that, that I'm capturing things properly here. The team 11 was a no-show. Team 13, low-cost multi-use solar emergency powerhouse, is not presenting, correct?
Well, I haven't gotten a response from them that they are. I got a message saying they were here, but I can't find them.
Okay, and now we're on to team 14.
Yeah, according to our sequence, yeah, and they apparently resolved their audio, so we'll move on to them. Yeah, team 11 appears to be a no-show. Yep. Team 13, I'm confused, but I haven't found them. Okay. So we'll move on to Trisol team 14 when they're ready, which looks to be now. Let's hope the audio works for them.
Hello, everybody. Can you hear me?
Great. Good.
Okay. I apologize for the audio issues from before. There was kind of a disconnect with the webcam, but I believe I've resolved it, but I don't have a video feed, but I do have another character playing video in the background, just to let you know. But without ado, let's bring in with introductions. So, hello, my name is Prathamesh Patel, and today I will be the lead presenter for today. In my current presence, I do have my team members, Saurav, Shrishti, and Rupesh, who are on standby for questions. And without further ado, I present to you an innovative 3-in-1 solar skylighting system named Trisol. Because there are many solutions in the solar integration market, the most widely used on the market includes photovoltaic panels to generate electricity, thermal panels to generate hot water, and skylights, which provide passive interior daylighting. However, each technology has an inherent weakness. PVs and thermal panels are often installed poorly and have a low conversion of efficiency of up to 20 to 60% respectively for each technology, while skylights just provide direct indoor lighting, so not much of its energy is being utilized in any other form other than for interior lighting. In order to take advantage of this opportunity, our innovation presents a combinational system that incorporates a single axis concentrating linear Fresnel lens to target and concentrate the sun on a highly efficient perovskite solar cell to produce electricity, in which a thermal absorber generates hot water by cooling off waste heat generated by the solar cells. So the unique selling proposition that Trisol offers is that it can start off as a minimal viable product that generates a combined efficiency of nearly 60% with an expected longevity of about 20 years due to its unique building integration within existing skylight frames. Even though there are a multitude of different skylight configurations, Trisol is a highly modular and low-cost solution that can be fitted or retrofitted within any skylight frame with a much greater efficiency than independent PV and thermal systems alone. Because Trisol is a combined PV, thermal, and skylight system, building owners can utilize the additional rooftop space for other opportunities, whether it be solar, photovoltaic, or a solar roof in general. So Trisol targets the philosophy of people, planet, and profit. The General Service Administration owns a diverse portfolio of 9,600 federal buildings, which presents a 354 million square foot opportunity to install Trisol, while California Title 24 requires commercial buildings greater than 24,000 square feet to install skylight and PV systems for building code compliance. In general, there is a 64 billion square foot opportunity to install Trisol across the US with the potential to generate 145 gigawatts of energy while reducing a significant amount of carbon emissions in the process. So the size of the commercial and industrial sectors are expected to reach 221 billion by 2026, while the global building integrated photovoltaic market is expected to grow to about 10 billion. And the global skylight market is estimated to meet a projected revenue of 4 billion by 2025. So in general, both markets are viable for Trisol, and the current demand for energy efficient buildings, with current demand for energy efficient buildings, these respective markets can be tapped in by Trisol. The main market channels that Trisol will target are OEM manufacturers for skylights and building integrated photovoltaic companies such as Velux, Vuaso, Onyx, and Prism Solar, but other market channels such as utilities who provide energy incentive programs and independent builders for construction and architecture will enable Trisol to penetrate the current market further and possibly even get a better foothold into the building photovoltaic market. The current business model that Trisol encompasses is a business-to-business model with a special interest to federal and public buildings. So our business will also serve to municipal, universities, schools, hospitals, and etc., wherever applicable. And we do have a pathway for commercialization. Trisol incorporates a 6-step program, which includes raising seed initially from the Department of Energy, Solar Energy Technology Office, to then finalize a pilot production program. So if there are any questions, please do ask them now. And I have my experts on standby.
Thanks, guys. I'm glad you were able to get your text situation worked out, because this is great. I actually have a couple questions for you.
Yes.
One is, I'll ask them first, and you guys can answer them in whatever order you want. I'm unclear on the application as a skylight, in that are they meant to essentially be built into a skylight where they offer diffused light into a space? That's sort of takes care of one of the disadvantages of regular plate skylights. Second piece is, are the units tracking? I'm assuming that they have to be oriented sort of perpendicular to the to solar exposure. So are they tracking, and do you have concerns about sort of the mechanical aspects of these sort of standing up to time with weather?
They're built into the skylight frame. In addressing your first question, they do have linear Fresnel tracking, so they will able to track the sun across its apogee. In addition to that, they're not exposed to the weather, so that creates a better weatherization program or wet weatherization utility. Instead of incorporating different paints or constructions, the trisol will just be within the skylight enclosure itself, so it's protected against the environment. The only issue would be just minor maintenance costs associated to just cleaning the panels seasonally. That's my only expectation for maintenance.
Gotcha, because the idea is that they're mounted on the interior side of the skylight. Is that accurate?
That's correct.
Great. Sounds good. Thanks, guys.
Thank you.
Okay, if the judges don't have further questions, we'll move on and return to team 15, I believe, Solar Cruise, electric scooters. I have this one, just double check. Yeah, I believe I've got that right.
Can you hear me all right?
Yeah, and you'll need to share slides, and the previous team needs to unshare. Yeah. Oh, you can try sharing on top of it.
Because I'm unable to while they're sharing.
Yeah, I don't have the power to unshare something. I'll send them a message. There we go. Excellent.
Hello, everyone. We are the Solar Cruise team from Rutgers University in New Jersey. I am Lucas Cruz, here with Rokia Tamraz, Francis Labuddy, and Professor Bernie. And our team designs and enables fully green personal transportation for the scooter fleet industry. So the problem with the current industry is that the scooter fleet operation is labor intensive, having to recall and fully charge scooters frequently. And the power that is used to charge the scooters is not green enough. And our solution is to incorporate the solar technology into battery powered scooter fleets, therefore reducing the amount of labor required.
So after the inception of our idea, we decided to do a little bit of background research into the actual marketplace that already exists for the electric scooter market. We had found that the US global market size for the electric scooter market is about $19.4 billion. And after finding out that we had a market that we could penetrate, we started to look into what it is our effect would be in these urban locations that we're going to try and implement our technology into. So as you can see on this graph, we had found that in urban locations for the 1 to 2 mile radius, we would be able to substitute our technology for about 21% of carpools. And you can see the rest of the numbers that are there. We found that for the 1 to 2 mile radius, that would be our greatest impact in those locations, as people wouldn't really want to take a scooter across an entire 6 to 5 mile difference, you know? So taking a look at our market ecosystem, the market ecosystem that is not in orange is the market ecosystem that already exists. We are trying to take part within the scooter manufacturing business, and we believe that we would have a strong penetration into this market, as we have the competitive advantage that allows fleet operators, who are our primary customers, to save labor costs, and that is required for keeping maintenance with these and charging them. And we also believe that this might be able to help our secondary customer segment, the scooter users, in their choice to actually use our scooters. In our future research, we would like to actually do a customer discovery and see if that is something that would impact the consumers' choice in actually using a scooter, a non-electric, a non-solar panel scooter, or a regular scooter that already exists within the marketplace.
So here at Solar Clues, we believe that we have a competitive edge if we were to launch solar scooters into the market right now. First of all, we are tapping into a well-established e-scooter market that is expected to reach a value of over $670 billion by 2028. Additionally, we have proprietary solar scooter IP that is developed at Rutgers that would enable this to be a successful commercial venture. And we are also, the solar industry is witnessing the lowest cost it has ever seen. Within the past decade, the price of solar modules has decreased by 64%. And in the past year, the price of solar modules for utility scale solar systems has decreased by 12%. So incorporating into the solar modules into our e-scooter design, which you can see in the lower left corner here, would be cost effective. Additionally, our beachhead market possibilities would include sunny locations such as Texas, California, and Florida. You can see in the NREL irradiance graph on the upper left corner here is that these areas receive increased solar irradiance throughout the year. Additionally, these areas, they have weather conditions that are favorable for scooter usage for longer durations of the year. So that, combined with the proven willingness of customers to use scooters in urban locations, we believe that we have a competitive edge as we launch solar scooters. So we just want to reiterate that at Solar Cruise, our mission is to enable green transportation while improving scooter fleet profit margins, and we'll be happy to take any questions now.
Okay, thanks. So, do the judges have any
Yep,
questions for this team?
I believe I'm up, Eric. Jamie Newtown here, so
yep.
Thank you, team. I just want to be certain you're going to design and build your own scooter, not retrofit existing scooters manufactured by, let's say, Bird. Is that correct?
Yes, we're planning on designing our own with the footing as the solar panels, correct.
Okay. So do you know what the current cost to construct on a per unit basis that Bird would be manufacturing at versus what you would manufacture at?
On a per unit basis, we have an estimate right now of about $100 as prices have been going down significantly for solar panels. We estimate to be able to resell them between $200 to $300.
The entire scooter with the solar panel built in?
Yes.
Do you know what your competitors are constructing their units for?
Not yet, but we could definitely look into it.
Okay. Thank you very much.
Okay, if there are no further questions, will the team please unshare? And we're fortunate to have caught up with Team 13, who will be next. They were not available when the time hit for them previously. So that's Lashawn Wong and his colleagues at New Jersey Institute of Technology. If you'll share your slides and we'll get going.
Hi, sorry, can you hear me now?
I can hear you. This is Eric.
Okay. Electricity may not be available when we need it most. This picture is taken after a severe storm last summer where power outage occurred in the neighborhood. The only power source available gets drained by dozens of cell phones just to get basic communication going. Have you ever bought a solar charger for cell phones, but ended up throwing them into garbage after playing just a few times? The problem is that most of the products, the portable solar chargers, have very limited capability, and some are only useful for daylight. For example, this type of charger is mainly used as backup battery. The solar module does not provide enough power to charge the backup battery inside. Most of the time, its own battery still use a wall plug to charge. In case of emergency, when there is relative high demand for even a small application, such as for a cell phone, most of the products in the market will not be able to solve this issue. Our technology and product solution provide options to enable needed power supply during emergency events. At the same time, still stay in the mobile portable solar charger space. We have much higher solar power generation and a much higher battery capacity for emergency needs. We have built in critical functions such as lighting, communication, and UV light for emergency needs. We have the form factor still small enough to be portable for mobile application. We have different modes for solar charge and for power supply, handling both daily use and emergency use. Our product is an ideal off-grid emergency power supply market. There are many applications to use our technology solutions. According to Grandview Research, the portable solar charge market first $1.7 billion by 2025 with a CAGR of 21.3%. For emergency situations such as in 2019, California alone has more than 2 million people lost power due to severe wildfire, and more than 60 million people live in hurricane zone in the US. There are great opportunities to create the right technology and the products for the people who needed them at the right time. Business mode. The product we develop can be direct sold to customers or in B2C mode. We will develop our own website or through other platforms, such as Amazon for distribution. There are also opportunities for demand-driven market, typically B2B, where we can provide our product as part of emergency kit. The product cost will vary depending on the specification. The entry product will have cost at $150 or lower. The team, including me and Mr. Jiaxing Zhang from NJIT, New Jersey Institute of Technology. The team also have a experienced industrial advisor, Dr. Kaijun Gao, at the International Business and Technology Service Corporation. Yeah, thank you.
Thank you. Questions from our judges?
Yes, thank you. Thank you for your presentation. You touched on this a bit, but what communities do you envision using this technology?
I think it's on for emergency use. There are a lot of communities will got power shortage due to severe weathers like wildfire or hurricane.
And do you see individuals, like individual households?
Yes.
Okay.
Yes.
Okay. Got it. Thank you. And what do you think it might cost to build this?
For now, I believe it's like $100 or so.
Okay. So, and then you think you would sell it for 150? Is that what that slide said, correct?
Yeah.
Okay. Thank you.
Just for now. Yeah. Thank you.
All right, if there are no further questions. Okay, thank you very much. Let's move on then. Then we're sort of cycling around here, but the next team on my schedule is Team 17, 4-quadrant meters spinning us into the future. The lead is Joshua Joseph at State University of New York, Buffalo State College.
Good afternoon. Can you hear me okay?
I can hear you fine. If you want to share, that's fine. If not, that's also good.
One second here. All right, can you see my screen okay?
Yes, thank you.
All right. All right, good afternoon. My name is Josh Joseph, and I'm a PhD student at SUNY at Buffalo. Today, I'll be talking about how our project works with synchrophasers and 4-quadrant metering in conjunction with battery energy storage, and explaining why formulating it into a business is fundamental in shaping the energy sector of the future. We're utilizing synchrophasers, which capture GPS timestamp magnitudes of voltage, current, and phase angles at a rate of 60 measurements per second. This enables us to capture a snapshot once every cycle, monitoring the health of the system conditions while incorporating the deviation at different nodes in the electrical apparatus. We're incorporating synchrophasers with a 4-quadrant meter to allow us to smoothly shift in between each of the 4 power quadrants. Since we know the magnitudes of voltage and current with respect to the phase angle displacement once every cycle, we can control the flow and direction of real and reactive power with battery energy storage. The implementation of this technology is compatible with the aging and evolving electrical grid. This project demonstrates that this can be a defining moment to include synchrophasers with any type of utility scale energy storage, since it's able to react to grid anomalies in cycles, preventing voltage reduction or load shed events. This project would allow utilities to maintain and test the controls of their own energy storage systems for companies like NextEra Energy, who already operate their own facilities. However, the New York Public Service Commission has newly approved tariff revisions directing utilities to contract out these battery services rather than run entire facilities themselves. In either scenario, our project provides visibility to the utilities and system operators with a real-time data-driven solution to keep pace with the increasing penetration of renewable generation. Our project offers regional transmission operators and independent system operators enhanced reporting mechanisms which provides the bulk power system with reliability, security, and resilience. Our control system supports essential NERC reliability services such as frequency response, ramping, and voltage support. Independently owned battery energy storage manufacturers who currently serve this market, such as Tesla, could offer real-time visibility for efficient operation and grid placement with utilities, system planners, and operators. Our project provides a blueprint by routing the needs and requirements of all associated parties in order to effectively operate grid-connected energy storage systems. Current costs associated with controls for utility scale energy storage consist of a programmable logic controller, a PLC, control software, and labor for installation for approximately $17,000. With our controls for utility scale energy storage at a third of the cost, we have successfully programmed a battery storage system to react in changing grid conditions in a time frame of cycles, thus enabling a smaller response time to what is currently offered at a lower price. We can offer our customers a valuable product that is realistic to implement. The big picture here is that we're providing the utilities and energy storage companies common ground on how to control and monitor energy storage systems. Both entities will benefit from our project since both have a need for a control system that is fit to handle the future constraints of a higher penetration of renewable energy resources connecting to the grid. By using synchrophasers, we're able to provide additional monitoring of current system conditions. Our project was kept simple for ease of use. As the aging electric infrastructure is being upgraded at different rates in different regions, this technology can be easily implemented as those transitions occur. The project so far has proved in the lab setting on a simulator for geothermal heat pumps with battery storage backup that this methodology is in fact worth pursuing. We have completed a cost comparison to what is currently being offered in terms of control systems for battery storage systems in a utility scale setting. The next phase of our project is to place controls and a battery storage system in a controlled environment. We have been in communication with a company who constructs battery storage systems and is interested in our project, and we would use the funding to purchase the necessary equipment to begin real-world testing. Thank you for your time and listening to how we envision this product becoming a fruitful business. We believe in keeping things simple for a smooth transition as renewable generation begins its deeper penetration across the electrical apparatus in the US. Does anybody have any questions or comments?
Thank you, Josh, for that presentation. Two questions. One, and maybe I just didn't catch this. Who do you see as your competitors?
Anybody who's an independent battery storage manufacturer or either a public, like a private utility who's currently controlling battery energy storage. We would just provide them a tool that would allow them to operate their equipment more easily, and it could implement with other different forms of renewable generation that surround the grid for grid stability.
Okay, and when you think about, as you envision this potentially rolling out, how do you imagine this supporting, a variety of different communities, including disadvantaged communities?
Right now, the project that we've worked on, that we've simulated, and it's with, we've partnered with an engineering firm where we proved that the synchrophasers would work with the 4-quadrant meters in a low-income urban residential area. So we basically had geothermal heat pumps with battery storage backup. And then we had like a urban resource development center, and we coordinated all those together.
Great, thank you.
You're welcome.
Okay, thank you very much. All right, so the next team up is led by Anthony Thompson of Columbia University, green methanol synthesis via sequestered carbon dioxide.
Great, thank you. Okay, so my name is Anthony Thompson. I'm part of a team of 4 graduate students from Columbia University. The technology being presented is the production of methanol by a new sustainable method. Green methanol is synthesized by an exothermic reaction which hydrogenates high-pressure CO2 that has previously been sequestered. For this analysis, CO2 is available using direct air capture called DAC, hydrogen is obtained from water electrolysis, and electricity is procured via solar PV panels. In addition to resulting in a net decrease in atmospheric CO2, renewable methanol also reduces NOx emissions by 80% and completely eliminates SOx and particulate emissions. Currently, methanol is generated 65% from natural gas, and the rest comes from coal. Most commonly, methane is reformed to syngas using steam and then distilled to liquid methanol. Today, there are 3 common industrial sectors in which methanol is used. The first and most significant is for chemical processing, which comprises about 63% of methanol use. These end uses rely on methanol and cannot be replaced with fossil fuel alternatives, making this a particularly challenging area to decarbonize. Chemical processes that use methanol include petrochemical manufacturing, pharmaceutical applications, medical equipment components, silicon processing, plastics, and polymers. The second sector is for transportation. Methanol can be blended with gasoline in traditional car engines and can be used to produce dimethyl ether, which is a diesel replacement. It can also be reduced to gasoline and olefins if needed. The third sector is for power generation. For example, methanol can be used in a fuel cell and the CO2 be resequestered, or it can be used more traditionally in a generator. In addition to what was just described, renewable methanol also adds 3 additional sectors. The first is a long-term energy storage solution similar to a battery. Methanol is significantly more power dense than a battery and doesn't have to be pressurized like hydrogen storage tanks. The second additional sector is an energy transfer medium. The pumping energy from methanol is magnitudes lower than high voltage power lines for electricity, for example. Lastly, the third added sector is carbon sequestration potential. This process results in a net reduction in atmospheric CO2 and can be used as a tool to reverse climate change. Methanol is a particularly versatile product with a market size around $3 billion in the US alone. In North America specifically, over 85% of methanol is produced from natural gas. From 2015 to 2020, methanol demand rose 4.5%, and the methanol market report forecasts a 5.5% increase in future years. The major players in the US markets are also shown on the slide. Our technology aims to help the methanol industry transit to a more sustainable manufacturing model by integrating a number of renewable industries. Our startup will serve as a bridge between methanol production companies, high CO2 emitting industries like cement manufacturing, and solar panel companies, providing them with a clean technology solution. As a result, all these companies are our potential customers. Green methanol is a unique renewable energy source and that has the potential to reach negative carbon emissions. Also importantly, green methanol will decrease the use of shale fracking, providing jobs with lower risk of radiation and dust exposure, protecting the health of employees in the energy industry. The chemical process of synthesizing green methanol has been studied in depth, and all processes required are commercially available today. After the methanol undergoes a series of purification steps via vaporization vessels and distillation columns, methanol is obtained with a purity of over 99%. In order to determine the economic feasibility of renewable methanol, 3 cases were examined. The first is the traditional case where methanol is reformed from natural gas. For the second case, direct air capture devices, PV cells, and electrolyzers are purchased to produce CO2, electricity, and hydrogen on site for green methanol synthesis. For the third case, pressurized CO2 and hydrogen are purchased from commercially available sources at market rate, and green electricity is purchased from a provider. With no premium or incentives, green methanol has a rate of return greater than escalation around the year 2040, at which we would expect sustainable methanol production to outpace the production of fossil fuels. If DAC technology improves at a rate greater than expected, this number can be reduced by 5 to 10 years. At a $1 premium, green methanol has the same commercial viability of traditional methanol. This $1 premium may come partially from consumer willingness to buy green, but is mostly expected to come from incentives for investing in green technology and from a lack of associated carbon fines. For example, in New York City, Local Law 97 will be enacting a carbon fine of about $270 for every ton of CO2 emitted over the allowance. It is equally important to look at the projected outlook of traditional methanol. As the cost of fossil fuels rise in coming decades, traditional methanol production has a decreasing rate of return on investment and is likely to be a failing investment by 2050. At the same time, the rate of return on green methanol investments will increase rapidly in coming decades. There is a strong existing market for methanol in both the United States and abroad, with no current means for sustainable production. Most methanol applications depend on its chemical properties and thus cannot be replaced with another sustainable alternate. Therefore, this is a viable approach to decarbonize the most difficult applications that are not currently being addressed. Thank you. Do you have any questions?
Thank you. Questions from our judges?
Yep. Thank you, Anthony. I appreciate it. This is a very intriguing presentation. A couple questions. One is, I think, similar, and I think you said it. this technology or this methodology, it can use captured CO2 from other sources, correct?
That's right. Yeah. So we looked at using direct air capture because that was the most expensive. Ideally, you would pair up with like a cement manufacturing or steel company and get point source CO2, and that cost comes down significantly.
Yeah, I've seen presentations from other. This is sort of a bit of a tangent, but I've seen presentations from other newer companies. You mentioned Local 97, where they're utilizing carbon capture technology in older buildings with fuel oil or other natural gas burning appliances, capturing the carbon and then shipping it out to cement manufacturing for sequestration. The second piece is speak a little bit to the potential, if you've looked at it, to the fuel. I know that you mentioned a replacement for diesel. Can this technology be used as a replacement or an additive for sustainable aviation fuel?
Yeah, that's a really good question. So one of the issues that we see with sustainable aviation is just like the batteries and things like that make it so less efficient to fly that they become prohibitive. And yes, the answer is you could. One of the things that's an issue is even when you start to make like gasoline out of methanol, methanol is about half as energy dense as gasoline. So the tanks would have to end up increasing in size, and that has the similar issues to batteries that you increase the weight. But generally, yes, you could use it as a fuel there as well.
Got it. Got it. Great. Thank you very much. Appreciate it.
Thank you.
Okay, thank you. So we're approaching the last of the scheduled presentations. And we will show the video we weren't able to run earlier right out. That's from Vanessa Chen and the Office of Technology Transitions. We'll show that right after the last team. There'll then be a break of about a half an hour while the judges confer, and then we'll convene again to announce the results of the judges' deliberations. And in addition, there'll be some opportunities to fill out a survey and some things like that during the break. So please do that. Okay, so the next team is State University of New York at Binghamton. The title is Pantheon of Carbon Negative Cement Replacement. And it's presented by Jacob Kumpan and colleagues.
All right, how are you?
Hi. Okay. So we will share slides and now.
All right, so hi, my name is Jacob Kumpan from Claw Industries. And at Claw Industries, we solve two problems. First, each year in the US, 8.3 million tons of glass is sent to the landfill. This is due to the high amount of paper, plastic, and metal contamination in the glass. Totally switching gears, I want to talk about the concrete industry. Now, concrete, like you see in the sidewalk, is made of gravel, sand, cement, and water. The cement and water react, creating the glue that holds the concrete together. Now, cement accounts for 8% of global CO2 emissions, one of the highest polluting materials of all time. At Claw Industries, we are paid by recycling facilities to take this waste glass. We then put it through our patent pending process and create Pantheon. Pantheon is a partial replacement for cement and concrete. Pantheon replaces 30% of cement and concrete to increase the compressive strength by 11%. The next step for Claw Industries is to implement mechanically assisted chemical exfoliation. Exfoliation is a process in which glass is used as a solid absorbing material for carbon dioxide. Mix directors at ready-mix concrete plants need a lab-proven solution to lower the embodied carbon of their concrete for the conservative construction industry that they serve. Additionally, they need a solution that doesn't require additional infrastructure due to the space and funding constraints that they face. Now, we work with two target markets. First, we work with operations directors at recycling facilities. Operations directors at recycling facilities that use 2,000 tons of glass per year include Al Sabino from Casala and Shalene Taylor from Taylor Garbage. Additionally, on the concrete side, we work with mix directors at ready-mix concrete plants. I'm sorry, is there a problem with the Zoom slides?
Yeah, I think some of the Zoom boxes are obstructing your slides.
Oh, is that better now?
That's better now. Yeah.
All right. Thanks. I apologize for the delay.
No worries.
All right. On the concrete side, we work with mixed directors at ready mix concrete plants that utilize 3,000 tons of cement replacements per year. This includes mixed directors like Tim Rufo from Barney & Dickinson and Eric Winter from D.A. Collins. Tim and Eric are currently paying high logistics costs to source low quality cement replacements. Using our patent pending process, our competitive advantage, we can provide Tim and Eric a lower cost, higher performing solution to decrease the embodied carbon of their concrete. Our total addressable market is 1.3 billion, with a service obtainable market in New York of 26 million. Now, to validate these target markets, we've completed 19 concrete projects and have received payment for over 20 tons of waste glass. Now, injecting carbon into Pantheon will open up a third revenue stream for us, increasing our profit margin to 17%. To put some broad numbers on these, we are paid $168 per ton Pantheon sold. Our cost of goods sold is $87 and our fixed cost is $58. Now, our technology serves disadvantaged communities that have historically been sent high embodied carbon concrete. With the New York State Pollution Prevention Institute, we validated that Pantheon reduces the embodied carbon of concrete by 30%. Then demonstrated this in 2 projects, including a residential sidewalk in Binghamton, New York, and a low carbon bike path at Clarkson University. Our role in the energy transition is to bring low carbon solutions to legacy industries using our modern waste stream. We would like to be considered for the CDR bonus prize based on our carbon reduction technology. At Claw Industries, we define success by the number of pilot projects we complete with mixed directors and their engagement. To deploy this new technology, we will continue our successful track of working with mixed directors and then implementing their feedback and deploying the technology in pilot projects. Additionally, we will utilize our 6,000 square foot facility in Binghamton, New York that we recently purchased this past summer. To address this market opportunity, we have assembled a strong team of co-founders. In addition to this, we have also assembled an advisory team to fill our management and technical gaps that we have. And at this point, I'll open it up to any questions.
Okay, thank you.
Thank you, Jacob. So you mentioned that you had a couple of demonstration projects. I think you said Clarkson University and 1 or 2 others. I was just curious because you went quickly over that last slide. Obviously, you've got to meet some of the standards that are out there. You mentioned ASTM. Where exactly do you stand in that process?
So currently, we've received ASTM C 1866 certification. That means that this material can be used in any general construction project that doesn't take place on a road. We are currently working with the New York State Department of Transportation to receive approval for roads and bridges. But really, we're focused on deploying this technology to non-mission critical projects like house foundations and sidewalks.
And what are your cost implications on, let's say, a per yard basis?
For a mixed director on a per yard basis, we save them somewhere around $6 to $8, depending on the amount of cement that they replace. The reason for that is cement is the most expensive part of concrete, and we reduce that cost by about 25%. So if you use more of our material, you save money yard over yard.
Gotcha. And Andrew has a question for you too, I believe. So, thank you.
Yeah, thanks, Jacob. This is again, these are all fantastic presentations. This is another one. In our current work, we often use, I'm familiar with glass pozzolan technology in the powder. And I apologize because you may have said this earlier. Am I correct in understanding that this technique is using glass pozzolan, but also are you binding carbon dioxide to it as a carbon sequestration method?
Yes. So currently we've produced in our basically scaling our regular glass pozzolan, the next step that we want to take is to implement actually injecting carbon into that. And that's how we want to make this actually carbon negative. So that's the next step.
So backing up, this is how would you differentiate from other glass pozzolan competitors?
Yeah, so there's two big things. The first one is we specialize in taking highly contaminated waste glass. So that's not just recycled glass, that's recycled glass that is up to 40% contaminated with other materials like ceramics and like heavy pieces of metal that's extremely difficult to get out. That's what our patent pending process is centered around. So that's our first competitive advantage, and we're looking to exploit this carbon aspect as our second.
Got it. Awesome. Thank you.
Yep.
Okay, that's great. Thanks very much.
Thank you.
So Eric, sorry to interrupt, but you're muted.
Again. Well, we'll start over again. Anyway, the judges are retiring to a Zoom room to do their deliberations. We're going to show a video, excuse me. We're going to show a video, the missing video from the beginning from Vanessa Chan that basically welcomed everyone to this competition. And then there'll be an opportunity to fill out a survey, and the judges will return with their decision in about a half an hour. So if Carrie is available, we will, well, let's see, we'll try again.
Welcome to the inaugural EnergyTech University Prize Competition. I'm Vanessa Chan, the Director of the Office of Technology Transitions, or OTT for short, and also the Chief Commercialization Officer of the Department of Energy. As a sponsoring office of EnergyTech Up, I can say that all of us here at OTT are humbled by the fact that we've seen a huge surge of enthusiasm from student teams, colleges and universities, incubators, and energy industry organizations. In fact, with 180 total applications from 113 schools, our inaugural cadre of teams represent 42 states, plus the District of Columbia and Puerto Rico. Not too shabby for our very first one. My thanks go out to my team at OTT, to the invaluable support we received from the National Renewable Energy Lab team, our partnering regional conveners, as well as the students themselves for their hard work. My vision for the goals and outcomes of this competition are: 1, to strengthen the energy innovation community across the US and territories; 2, to identify business opportunities for young entrepreneurs; and 3, to help lay a talent pipeline that will secure our energy future. We hope you all can take this opportunity to network and get to know the work going on in your region, because collaborators across schools catalyze future partnerships. Our mission at OTT is to help shepherd technologies through the research, development, demonstration, and deployment, or RD&D continuum, to ensure they are commercialized and brought to the market. You're about to hear several inspiring, innovative ideas to do just that. This is an exciting time to be a budding entrepreneur, because a clean energy transition is upon us. It will be revolutionary for our world, and we need all hands on deck to make it happen. Today, you are all on deck to play a role as you think and work towards that future. The students of today are the innovators, scientists, marketing specialists, policymakers, and entrepreneurs that we need. So with that, good luck, and may the best business plan win. But not to be too cheesy, you guys have all won by participating, because this is what we have to do to go hit our climate targets. Good luck.
All right. I'm sorry that he couldn't show that earlier, but a fairly good conclusion as well. Let's see, Carrie, if you can throw up your slide with the QR code for the survey. It's now, let's call it 4:15, so the judges will endeavor to be back by 4:45.
And Eric, may I jump in and say a couple words here?
Of course.
Hi, everybody. My name is Lauren Shum. I'm also from the Office of Technology Transitions, where you just heard from our director, Vanessa. And I just wanted to give my heartfelt thanks to the whole entire Syracuse team, Eric, Tammy, Carrie, and Katie, and Iserta, You've done a fantastic job organizing this event. We're just very grateful. And we're also grateful to all of you students. We are so delighted to have heard such great presentations. And as Vanessa said, may the best one win. So thank you all very much. And I'll also put in a plug for our survey. This is the inaugural year of our competition. And so we are really looking for feedback. What went well? What didn't go well? What did you learn? Any feedback that you provide us will really help as we develop next year's program. So thank you very much.
Okay, welcome back, everyone. And thanks for your patience as the judges worked feverishly to make some decisions. So Carrie, if you'll show the first slide, I'd like to announce the teams that were selected as technology area semi-finalists, who will be considered further for possible other good things. Okay, they are in the technology area of fossil energy and carbon management. Pantheon, a carbon negative cement replacement, and that team was led by Jacob Kumpan at SUNY Binghamton. And the other technology area for which a semi-finalist was selected is solar energy, and that semi-finalist is the Trisol team, a 3-in-1 solar skylight system, and that team was headed by Prathamesh Patil, University of New Haven. Finally, I would like, very pleased to announce the regional finalist who will go on to competition and will receive an award. So if you'll show the next slide, I will get the phrasing correctly. All right, that was team number 4, University of Connecticut, led by Islam Mosa, Smart I4. So congratulations to that team. And they will be competing, definitely competing for the next stage. So that's our regional winner from our region, of which there are 11 regions. Okay, so let me just finish up by thanking all the teams. The judges spent longer than you might think because there were so many excellent teams and highly competitive presentations. So congratulations really to all of the teams. That was fantastic. Our energy future really belongs with all of you, and these innovations, and especially the ones you bring to market, will have a huge impact on energy challenges in general, issues of equity, issues of carbon. You can all be very proud of these efforts, and we look forward to hearing of all of your successes, not just the ones who were selected today. And thanks very much to the judges. They were really great and very experienced and knowledgeable. It was really great working with them. And of course, our hosts at New York State Energy Research and Development Administration and the Clean Tech Center in Syracuse. And of course, the Department of Energy sponsored this competition, and the Office of Technology Transitions is appreciated for sponsoring the prize and organizing the whole competition. So, all right, thanks to everyone, and we hope to see you another year.